Good morning. Welcome to MOOC course on analog electronic circuits, week 2, second lecture. So, lecture 1 of week 2 has been discussed about mid-frequency analysis of RC coupled BJT amplifier. Now, in this lecture, we'll see the high frequency analysis. So the continuation to the last class, last session, high frequency case, where we need to see the effect of internal capacitors. So all external capacitors will be short circuited. So we'll redraw the diagram of last session with considering only internal capacitors, short circuiting the external capacitors. So this is the diagram. Vs, Rs, RBB dash, RB dash E, C is CB dash E plus CB dash C into 1 plus GM RL dash, and the voltage across this parallel combination of resistor and capacitor is VB dash C, dependent current source parallel with capacitor, internal capacitor and load resistor RL dash, taking the voltage across the load resistor. So similar to the last class discussion, V0 is equal to the load current is flowing through the parallel combination of, this is considered as Z2. Z2 is parallel combination of XCB dash C with RL dash. So V0 is equal to IL into Z2. IL and GM dash C current source are opposite in direction. So IL is equal to minus GM dash E. So Z2 is the parallel combination of resistor and capacitor. So parallel combination was computed. RL dash multiplied by 1 by j omega CB dash C by RL plus 1 plus j omega CB dash C. Simplification of this leads to RL dash by 1 plus j omega CB dash C into RL dash. So, substituting the same in the above equation, V0 is equal to minus GM dash C. In place of Z2, we are substituting this value. RL dash divided by 1 plus j omega CB dash C RL dash. This is output voltage. Similar analysis will be done to input side. Input side, the current flowing through the circuit is voltage source Vs divided by Rs plus RBB dash plus Z1. Z1 is the parallel combination of RB dash E XC. C is the capacitor that parallel with RB dash E. So similar thing, Z1 is equal to RB dash E divided by 1 plus j omega C RB dash E. And VB dash is the voltage drop across the Z1 resistor. So VB dash is equal to Vs into Z1 divided by Rs plus RBB dash plus Z1. Substituting Z1 equation here. So Vs into RB dash E by 1 plus j omega C RB dash E divided by Rs plus RBB dash plus RB dash E divided by 1 plus j omega C RB dash E. A mathematical simplification of this equation was given in this slide. So numerator simplification and denominator simplification, that is Vs RB dash E by 1 plus j omega C RB dash E. 1 plus j omega C RB dash is taken LCM. So 1 plus j omega C RB dash E multiplied by Rs plus RBB dash plus RB dash E, and this gets cancelled. So VB dash is equal to Vs multiplied by Rs RB dash E divided by Rs plus RBB dash plus RB dash E plus j omega C RB dash E Rs plus RBB dash. So Vs into RB dash E, I'm taking common from the denominator Rs plus RBB dash plus RB dash E taken to the numerator. So this component is taken common, so we'll get 1 plus j omega C. The remaining part is RB dash E multiplied by Rs plus RBB dash, and we are taking the common here, not the term is not there. So we'll make it substitution here, Rs plus RBB dash plus RB dash E. So this can be written as VB dash E is equal to RB dash E into Vs by Rs plus HIE 1 plus j omega CR. R is considered as this component. Complete component is considered as R. That is parallel combination of RS plus RBB dash with RB dash E. RS plus RBB dash parallel with RB dash E gives this value R. So substituting this VB dash E is simplified equation to the equation 10 gives V naught is equal to minus GM RB dash E Vs divided by so this is AVHF making all substitutions minus GM RB dash E multiplied by RL dash divided by RS plus HIE, that is 1 plus J omega CR from one side, 1 plus J omega CB dash C RL dash from other side. So making it simplification, GM RB dash E is HFE. So minus HFE into RL dash by RS plus HIE is the mid frequency voltage gain we discussed in the previous lecture. So that is AVMF denoted by divided by 1 plus J omega plus we substituted 2 pi F J 2 pi F CR 1 plus J 2 pi F CB dash C RL dash. So making it comparing with the equation of RC filters discussed in the very week 1 lecture 1. So making substitution here, F21 is equal to 1 by 2 pi CR. F22 is equal to 1 by 2 pi CB dash CRL dash. So which becomes the equation AV high frequency is equal to AV mid frequency divided by 1 plus J F by F21 multiplied by 1 plus J F by F22. This resembles, the all parameters are given here, what is R, what is C, again given here for the sake of simplicity. So equation 11 resembling that cascade of two low pass filters with cutoff frequency F21 and F22. We have seen there in the low pass filter discussion. This is the equation. If you compare it with this is one low pass filter, this is one low pass filter. So cascade of two low pass filters, the final cutoff frequency is a minimum of 2, minimum of F21 and F22. So F2 is equal to minimum of F21 comma F22, which gives the overall the upper cutoff frequency because of external capacitors, sorry, because of internal capacitors. So that's all for this session. So here we have seen the high frequency analysis of BJT RC coupled amplifier. Thank you.